Dr. Oliveira, and welcome to the GI Health Summit. Thank you so much for taking the time to talk to me today.
My pleasure, AJ. You know, I absolutely adore talking to you. Anything that you produce, put together, you can always count me.
Oh, that's great. You're one of my favorites. Thank you.
So I thought that today, I usually talk about weight loss. As you know, I love talking about that. And today I wanted to talk about weight loss as it relates, or gut health as it is related to weight loss. And I thought I would start with a few slides because visuals can be very helpful. And then after I give a short presentation, and we can come back and chat, which is something that you and I love to do. So if you allow me, I will share my screen. And I have my slides here. And we'll start. So I want to talk really specifically about whole food plant-based diets and weight loss, and what is it that the gut has to do with it. Because when we talk about weight loss, most often than not, people believe that it's simply a matter of math. It's calories in and calories out. As long as you eat less and you burn more, you have absolute no weight problem. And this is way simplistic. And if it were true, what we would expect is anybody who has ever tried to lose weight by counting calories or reducing their caloric intake and exercising to increase their caloric expenditure would have lost weight and would have been able to keep the weight off. And that's not true. And the other thing that happens is that even among us who follow a whole food plant-based diet, we know that people eat on average between 3 to 5 pounds of food every day. And then we tend to do this or go on the same simplistic explanation where we expect people to believe that the reason that a whole food plant-based diet works is because the foods are naturally low in calorie, which is true. And as long as you eat 3 to 5 pounds of food, they are in the lower range of the energy density, you are set. But again, if it was just a matter of calorie, anybody who would reduce the caloric intake would have the same results. But there's something about whole plant foods that is related to gut health that makes all the difference. And that's what I want to talk about today. So when we talk about weight loss, so appetite and body weight control, that happens in the brain. So the hypothalamus is responsible for food intake and for energy expenditure. And there are signals that come from the body into the brain that will be regulating that, regulating our appetite and regulating how much food we eat and regulating how much energy we get to expend every single day. And there are long-term signals coming from basically adiposity signals, like how much fat we already have stored in our body. And there are short-term regulators, one of which is ghrelin, we're going to be talking about today. So all of these hormones or peptides or other molecules send signal to the brain that tells us whether or not we're supposed to eat more or eat less. When it comes to ghrelin and leptin, they control appetite in different ways. As I mentioned, leptin is a long-term regulator and ghrelin is a short-term regulator, which means ghrelin will tell you whether or not to eat more or less on a meal-to-meal basis, while leptin tells you whether or not you need to eat more or less on a week-to-week basis or month-to-month basis. It's long-term because it's based on your reserves, how much fat you have already stored to say, do you need to store more for a rainy day or not? So, but basically, when we are hungry, before we are about to start eating, ghrelin is expected to be high. That's how we feel that we are hungry. And leptin is supposed to be low. And then once we eat, the reverse happens. Then ghrelin goes down and leptin goes high. And this communication between our stomach and our gut and the brain is what we call this brain-gut axis. So the communication occurs from the brain to the gut and from the gut to the brain. And we need this communication to be happening in the most perfect way for the body or for the weight to be the weight that we want. So for us to be able to lose weight and to keep the weight off, this brain-gut axis needs to be working properly. And the big difference between just eating foods that are low in calories, like when we are just counting calories on a diet, and actually eating foods that have low calorie, but have something else that it makes a difference, and that something else is fiber. So whole plant foods have fiber, and fiber is essential for gut health, and fiber is essential for weight loss and to keep the weight off. And the reason for that is that fiber is not something that we can digest. We have just a handful, a little more, like a dozen or so more enzymes there are in our bodies. They're able to break down fiber. So we need the help of a gut microbiota, of our gut microbes, to be able to digest this fiber. So if we have fiber in the diet, and it can fiber or resistant starches, so those are starches that resist digestion until they get to our colon or large intestine. So when we have fiber and resistant starches getting to our large intestine, that's when our gut microbes go to town, because they have over 60,000 different enzymes. They are specifically made to digest this type of food. And then when the gut microbiota digests fiber, they produce short chain fatty acids. And there are 3 of them. There are more prevalent than the others. They're acetate, propionate, and butyrate. And they are all magical in their own way. They all have something, an important role to play when it comes to this communication between the gut and the brain, and when it comes to weight loss. So when we look at the enterocytes, or the cells in our intestine lining, we see there are some specialized cells called L cells, and they have receptors at the top that can sense different signals that come from short chain fatty acids, that also come from macronutrients that we eat, carbohydrates, proteins, and lipids. And these L cells then, when receive the signals, they will produce certain peptides that are going to then send signals straight to the brain to say, we've had enough to eat, we are fine, thank you very much. And 2 of those peptides would be GLP-1, or glucagon-like peptide 1, and PYY, or peptide YY. And the difference, so they're both produced by intestine they're produced by the L cells in the intestine once our gut microbes have the opportunity to digest this fiber and produce short chain fatty acids. So GLP-1 will do a few things. 1, it will increase insulin release that is directly related to the amount of glucose that we have in the body, which is what we want. If we have more glucose, we have insulin being released so that we can then send the excess glucose to the muscles and then to the liver as storage for us to be able to use between meals. But GLP-1 also will have a direct effect in our brain, telling our brain that we shouldn't be hungry, so hunger goes down and satiety goes up. But two other things that I love about GLP-1 is, 1, it slows the emptying of the stomach. So it makes the food goes slower in the stomach. And when that happens, then the stomach tends to distend more, and is another way that we feel full, like less food is necessary for us to do that, and it continues to go. And then GLP-1 also has an effect on the brain stem, and it increases thermogenesis. So it says it's time for you to move more and burn more. And PYY also will send a signal straight to the brain that is going to increase satiety for prolonged time. And they work synergetically, meaning the more GLP-1 and the more PYY, the more the brain receives signal that we've had enough to eat and we don't need more food. So it's going to be controlling our appetite this way. This looks like a very complex slide, but it's very easy to understand. And I'm going to go through everything very slowly. So let's see, right now you eat. Once you eat, we have nerves in our stomach that will be receiving signal like stretching, like mechanic receptors. They're going to say, yes, okay, I've eaten, the stomach is getting full, and it's going to be sending signals to the brain and say, something's going on, we have food. But there's also other molecules being released, cholecystokinin or CCK is also being produced and sent to the brain saying, I'm eating. So it's another peptide with what we call anorexogenic effect, meaning it's going to bring our hunger, our appetite down. And then we have those CCK the signal goes through the vagus nerve, and then it gets to an area of the brain that is called the NTS. That's the satiety center in the brain. So it's CCK coming from the intestine. Once we eat, goes to the same region. And then there are leptin, insulin, and PYY. They are being produced and released and going to the brain. It just goes to a different part of the brain that I'm going to show in the next slide. But they also will have an effect in bringing down hunger and bringing satiety up. And then the signal goes back to the NTS, which is the satiety center. So in the brain, this is what we see. Remember I said that insulin and leptin are two hormones that have long-term effect in food intake and energy expenditure. So when insulin and leptin get to the brain, they're going to be working on two different types of clusters of neurons. They have weird names. They are there. I don't know if you want me to read them out loud, but the green one, this cluster of neurons called agouti-related protein or neuropeptide Y, they are supposed to increase hunger, increase food intake. And you can see that both insulin and leptin have a negative feedback, meaning when insulin and leptin are high, they tell that cluster of neurons to downregulate, not to shut down completely, but to be, the activity needs to come down. And then when that happens, then your appetite goes down. And at the same time, they have an effect on the pink cluster of neurons called POMC-CART. And then those are supposed to bring the appetite down. So that's how it works. And on the other hand, just so you understand how ghrelin works, remember ghrelin is the only, up until now, the only peptide has been described that has an orexigenic effect, meaning increased appetite. And ghrelin only will have an effect on the green cluster of the neurons, the agouti-related protein and neuropeptide Y, which is supposed to increase food intake. And I say green and pink, it's not that we have green and pink neurons, it's just the cartoon representation, but that's how it works in our brain. Then when we eat foods like beans, for example, beans are very high in both fiber and resistant starches. And those foods, they're high in both fiber and resistant starches, get to our gut, and they're going to have all these effects that I've just described. And one of the effects, it's called, or it's known as the second meal effect. It used to be called the lentil effect. And that is the known effect that we know the short chain fatty acids are going to have on glucose metabolism or glucose control, which means that if you have a meal right now that has beans in it, so it's high in fiber and resistant starches, we expect the short chain fatty acids are going to be produced. Of the three that I mentioned before, propionate's going to have a very direct effect on the stomach, just very similar to the effect that I described for GLP-1, which is to slow the emptying of the stomach. And when that happens, then the food is absorbed more slowly. And that's how glucose control happens. And the second meal effect is so strong that if like two people now eat, and they've shown that in clinical studies, and that's why I mention it, because that's exactly what they did. They compare two groups of people. One group would be eating bread in one meal, and the other group would be eating lentils or different types of beans. And then in the second, and then right now, bread and beans, so both together. And just the presence of beans would make the glucose to control to be better. So what we would see, the glucose response would be smaller compared to the group that would just eat a high glycemic food. But more importantly, even 4 hours after, or sometimes the next day, if the two groups would eat just bread without the presence of beans, you would continue to see that the glucose response would be down in the person or in the group that ate beans before. So it's something that goes beyond the meal that you have just consumed, because the short chain fatty acids will have a prolonged effect. And then there was another study where they compared beans versus calorie restriction when it comes to improving risk factors related to prediabetes. And they compared two different groups head to head, where one group had to consume 5 cups of beans a week ad libitum, meaning don't stop eating anything that you eat, just add the beans. And the other group had to reduce their caloric consumption by 500 calories, because they think one of the risk factors for prediabetes is waist circumference, so central adiposity, and they wanted to know if they could see an effect there. And lo and behold, after the experiment, at the end of the experiment, they saw that the effects or the reduction in the risk factor was very equivalent between the two groups. But one group was actually having to restrict calorie intake by 500 calories, and the other group was just adding beans, just to show the power of those short chain fatty acids they are produced in our gut when it comes to weight control. And this is a study that I like more than most of the other ones that I talk about. And this is the direct effect of short chain fatty acids and when it comes to craving. And this was also, it was a randomized clinical trial, crossover, meaning people that are in each of the groups had to receive all the treatment. So it's not just one group received treatment 1, the second group receives treatment 2, and then you compare. Now, everybody in the study receives both treatments. And what they did was they wanted to see if short chain fatty acids would change how your brain will respond to food cues, and whether or not also short chain fatty acids will change how much food you would eat. And so it was 20 healthy, non-obese men, and they were giving inulin, which is a prebiotic, and the other one was giving inulin propionate ester, meaning it was a way for them to be able to produce propionate, one of the short chain fatty acids in the colon. But people didn't know which one they received because both were added to whatever they were eating or drinking. I think it was a drink. And then they were put under functional MRI, and they were looking at the reward center in the brain. And they were showing pictures of foods that are high in calorie or low in calorie. And it could be pizza or ice cream, and it could be a piece of fruit, it could be cucumber, you name it. And they wanted to see how the brain reacted to those food cues. And they noticed that the group that received, or they were producing propionate, one of the short chain fatty acids, they responded a lot less. The reward center didn't light up as much as the group that did not have the short chain fatty acids. And they also ate less food, just to show, again, that it's not a matter of eating less calories. There's something magical in whole plant foods, which is the fiber, and sometimes the fiber and the resistant starches, that produces this magical molecules, short chain fatty acids, that have massive effects in our brain. It's really the gut and the brain being able to control your appetite, being able to control how you respond to food cues, being able to help you lose weight and to keep the weight off. So in our gut, we have about 39 trillion microbes, and most of them bacteria, an average 1,000 different species of bacteria. And then if we're eating the foods we are supposed to be eating, and I know we are biased here, we want everybody to be eating whole plant foods, what happens is that we are giving food to the good guys. The good bugs have an opportunity to eat, to digest this fiber, this resistant starches, and produce short chain fatty acids. And among the good guys that we want to have more of, we can have the lactobacilli, the bifidobacteria, and the prevotella. Those are the good guys. We want more of them. But then if we don't eat foods that are high in fiber, and going even further, we eat a very high fat diet, and not just any fat, but a diet that is very high in saturated fat. Something happens in our gut, and that something is called dysbiosis. Dysbiosis is when we have imbalance in our gut microbiota. And what happens is that whatever we are giving, the food that we are giving our gut microbiota, is not conducive for their own health or for our own health. And then the good bugs start decreasing in number, and the bad bugs, the ones we don't want, start increasing in number. And when that happens, we have something that is called leaky gut. And leaky gut is this. On the left side of this slide, you can see what would be a healthy epithelium, a healthy intestinal epithelium. So you see the cells, they are very tight with one another because there are tight junction proteins that keep the cells together, really connected. So it's very hard or almost impossible for a lot of things to pass through those cells and get to our bloodstream. But when we start eating a lot of saturated fat and high fiber foods, then this tight junction proteins, which by the way, one of the short chain fatty acids, butyrate, is what helps us create more, stimulate production of these tight junctions. But if we have the bad bacteria increase in number, and then butyrate, one of the short chain fatty acids, not being produced, we lose those tight junctions. And then the cells, we start seeing space between the cells. And then through the space, we start seeing all kinds of molecules being able to pass through the bloodstream. So this is what we call leaky gut. And one of those molecules that can pass through between the cells and get to a bloodstream is called LPS, which is part of the wall of the bad bugs, the bad bacteria that we don't want to even be in big number or to cross to a bloodstream. And when LPS, which is lipopolysaccharides, get to a bloodstream, it's going to stimulate an inflammatory response from us. So this is what I was explaining. So the inflammation, this is what happens when we eat high-fat, low-fiber diet. And then our immune cells respond by producing different molecules or cytokines, and one of them is called tumor necrosis factor alpha, or TNF alpha. And then this cytokine is going to have a direct effect in how our body can respond to insulin. So it's one of the reasons why a low-grade chronic inflammation leads to insulin resistance, because TNF-alpha and other cytokines will interfere with insulin signaling. But it gets worse because saturated fat itself has a direct effect on the receptor of insulin and will also cause insulin resistance. So just by changing what we are eating, we are changing the signal that is coming, the signals that are going from a gut to the brain. So when we have low-grade chronic inflammation, and when insulin is high, because low-grade chronic inflammation leads to insulin resistance, and saturated fat itself, the intake of saturated fat itself leads to insulin resistance. When you put two together, then when we eat, our response is, our signals to the brain are going to be different. So we eat, and when we eat, part of what we eat, we like to store for a rainy day. But then our adipose tissue or fat tissue produces leptin that in theory needs to tell the brain, we've had enough reserves. There's no need for us to store anything else. So the centers in the brain, satiety center, can say, yes, I've had enough to eat. So that was what should happen. The brain should see leptin and say, stop eating. But then when we have low-grade inflammation and high insulin, the brain becomes leptin resistant too, which means our body produces more and more leptin, but the brain doesn't see the leptin, as if we are starving all the time. That's why if you're just changing what you eat, but not how much you eat, but not what you eat, it's going to be very hard for you to reverse this leptin resistance, and your brain will continue to stimulate you to eat more. So, and this is how obesity then happens. And this is why it's so hard to reverse by just reducing what you're eating. Because if you're reducing what you're eating instead of changing what you're eating, you have no effect in your gut. You are not producing more short-chain fatty acids. They're going to send signals to the brain to say, yes, your appetite can go down, hunger goes down, satiety goes up. So when people lose weight by counting calories, something terrible happens, which is their leptin is constantly low and their ghrelin may be either high or it can be almost constant, meaning there's no fluctuation. And those two things are bad news because you're constantly hungry. That's why 2/3 of people that lose weight counting calories only, so just reducing the amount of food they eat, they gain all the weight they lost plus more, because ghrelin and leptin is one of the mechanisms, those two together, that our bodies have to make sure we maintain our highest weight possible. Because biologically speaking, they believe that if we have this high weight, we have tons of reserve and we're not going to starve. So it's going to fight through nails to keep the weight high. And that's why when we change what we eat and we start eating high fiber or whole plant foods, what happens is we produce short chain fatty acids, and short chain fatty acids stimulate the body to produce more leptin, and also helps us keep ghrelin low. So if you give someone about 24 grams of fiber, you can wait 4 hours. That person's still going to feel full as if that person ate 500 calories worth of food, because fiber makes us full because of the short chain fatty acids. So that's the biggest difference. If someone loses weight by eating whole plant foods, in the end, the weight loss is going to be sustainable because the foods are providing short chain fatty acids that keep ghrelin and leptin where they should be. And if you just try to lose weight by counting calorie, you will lose weight, but you'll never be able to regulate leptin and ghrelin, and the signals from the gut to the brain are always going to tell you to eat more. You're always going to be hungry. And just to finalize this short presentation, I just wanted to show that this starts very early. This is the diet, the difference between diet and gut microbiota in children in Africa, in Burkina Faso, eating sorghum-based diet, so whole plant food, versus kids in Europe, and those kids were in Italy. You can see that, and this has been shown in a different study, that people that have more Bacteroidetes type of bacteria versus Firmicutes, they will tend to be lean. And those that have more Firmicutes instead of Bacteroidetes will tend to be obese. So even though these kids may not be obese, we can see that the kids in Africa have the microbiota of lean people. But more importantly, even though we can see a lot more green, right, a lot more Bacteroidetes in the African kids, even when we look at this type of bacteria in the gut of European kids, the type of bacteria is different. So in the African kids, we're going to have more of Provotella, which is what we want. And in the European kids, we're going to have more bacteroids. And there was another study that showed that basically human beings can be divided into two different enterotypes. There are people that are going to have more bacteroids and people that are going to have more Provotella. And then the Provotella, just as I shown, it's the most prevalent type of bacteria in African kids who are eating whole plant foods. Those are the bacteria that are going to be digesting more carbohydrates compared to protein and fat. And those are the type of bacteria that we want to have more. So it's really related to the diet, to the gut, and the signal that is being sent to the brain. And the last thing I wanted to mention is the study that decided to do fecal transplant between humans and mice. They were germ-free, to show that the effect is related to the bacteria and the diet together, not so much the person. So they get pairs of twins that they say discordant for their BMI. So it was twins that had at least 5-point difference in their BMIs. And what they noticed is that the phenotype could be transmitted. So if you got the gut microbiota from the lean pair, for the lean of the two twins, and transfer to mice, you would see that the mice will remain lean. And if you transfer the gut microbiota from the obese twin to a germ-free mice, the mice would become obese, which shows that the gut microbiota is key. Then they went one step further and then compare that they wanted to see if the effects would be the same if they were following a diet that was low in saturated fat and high in fruits and vegetables, or basically low saturated fat, high in fiber, And they could see that what they were expecting to see, yes, the mice that received the microbiota from the obese twin gain weight, even on that type of diet, because they didn't have any other microbe of their own that could take over with a good diet. And the lean mice, or the mice that received the lean microbiota, they lost weight. But then when you put the two mice together, the one that had the obese microbiota and the one that had the lean microbiota, because mice tend to eat each other's poop, you could see transfer of microbiota, and now the mice that received the obese microbiota didn't gain weight. But the most important results came after, when they gave the mice a high saturated fat, low fruits and vegetables diet, and all the mice gain weight. Meaning, even if you have amazing microbiota, if you give this microbiota the wrong food, high saturated fat, low fiber diet, the tendency is weight gain. So gut health is essential for weight loss and for maintenance of weight. So weight maintenance. So if you want to keep the weight off, once you lose your weight, you have to make sure your gut microbiota is healthy. And the easiest way to do that is if you follow a whole food, plant-based diet that is also very low in fat, ideally with no added oil. That was pretty much what I wanted to say to start our conversation. I'm going to stop sharing. And any questions that you may have, I'll be ready to answer.
Oh, thank you. Well, the fecal transplant thing is fascinating, because I'm wondering if people are thinking, well, I don't need to change my diet. I'll just have a fecal transplant.
I'm sure a lot of people are thinking that, and I get this question a lot. I know that fecal transplantation is actually, the term is FMT, fecal microbiota transplantation. So you're only transplanting the microbes. And it's being used more for people that have chronic conditions that require them to completely change their microbiota. So it's not being used to treat obesity, but as you guessed, a lot of people want to do that. The thing is, and I don't have a slide to show you this, but there was a case study that I thought was fascinating. This woman who had a C. diff infection that they could not treat with any type of antibiotic. And she required a fecal transplant. And usually there's such a thing as a fecal transplant bank, just like there's blood bank. And you should accept the microbiota from a donor that has been screened, is healthy and such. And this lady, she refused. She didn't want to receive microbiota from a stranger, and she asked to receive microbiota from her daughter. And when she did that, both of them were had more or less the same weight. But once she did that, her daughter and the mother both gained 50 pounds over the course of the next 6 months, because her daughter had a microbiota that was already probably more leaning towards weight gain. And because they probably ate the same diet, the phenotype of the daughter was transmitted to the mother. So it's something that you cannot predict. But of course, with time, I don't see that as treatment. I see a lot of people trying to do other things. If you read the latest research when it comes to obesity and gut, what they've been trying to do is, how can we give people prebiotics or probiotics that will give them the type of bacteria they need to have in order to lose weight. But the thing is, they are focusing on giving GLP-1 or PYY to try and mimic what would happen if everything was working perfectly. But nobody's really paying attention that you have to be able to maintain the weight loss. And for you to be able to do that, you need to make sure that your good bugs are the ones that are in greatest number. And to do that, you need to make sure you eat a high fiber diet. So even if you have a fecal transplant, like we just showed, you can have the perfect bacteria. But if you eat high saturated fat and low fiber, you're still going to gain weight because the other guys, the bad guys, are going to outnumber the good guys. So unless you want to do fecal transplantation every 3 months or so, I don't know how often that would have to be, but diet should be always the focus. And if you're going to talk about other things that you can do, so first is eat the most fiber that you can in your diet. So a variety of whole plant foods, they are high in fiber and resistant starches. Then if you want, those are prebiotics, but there are other probiotics that go beyond fiber and resistant starches. And I bet other doctors already talked about other types of prebiotic foods. You can eat those too because they will help the good bugs to grow and outnumber the bad guys. And then the last thing would be looking into a probiotic, because a probiotic would give you the right bugs. And there are a few clinical trials they are looking into specific strains that have been shown to be in higher number in lean individuals, one of which is Akkermansia mucinifila. I don't know if anybody talked about it. There are clinical trials there where people are receiving this one strain, because in the general population, you would expect them to be about 2% of your gut bacteria. But in people that are lean, that do not have type 2 diabetes, you can expect to see them about 4.5%. And that makes a huge difference. So that would be my answer to you. I don't think fecal transplantation is the key, and it won't work because you have to change your diet too.
Right. Yeah. Just people are looking for an easier solution.
Always.
Yeah. So, you mentioned how having high fiber and low or no saturated fat is best. Have they ever studied it where people actually had high fiber, but also ate the saturated fat? Does one mitigate the other?
That's a great question. I don't know if they did that. I'll have to think about, because the key is always how much fiber. What is high fiber, right? So we know that according to the guidelines that we receive, we need to be eating about 14 grams of fiber per 1,000 calories that we eat. But most of us are really terrible at estimating how many calories we are eating and even quantifying the amount of fiber we eat. It's very subjective. And the other thing that we need to pay attention is, where is this fiber coming from? Because you probably know a lot of people that eat a very low fiber diet, very high saturated fat diet, and they take metamucil, or I don't know how you call it, or psyllium fiber, say, okay, I'm getting my fiber, but the effects are different because psyllium is great to help with volume and frequency of bowel movement, which will have an effect on weight, but it doesn't help us produce more short chain fatty acids. So the frequency and the volume of bowel movement will have an effect on weight, because they show lean people compared to obese people who tend to go more often and produce more poop than obese individuals. But just adding insoluble fiber to the diet, it won't help, because they won't be stimulating the production of short chain fatty acids. They're going to be promoting the release of leptin, or making sure ghrelin is also balanced. You won't be stimulating the production of GLP-1 or PYY. You won't have this gut-brain axis working as nicely as it should when you're eating whole plant foods, when the fiber is coming from the food.
Right. And fiber is only found in plants.
Of course, no animal foods have fiber, unless, so that's what I say, when we talk about the ketogenic diet, They are adding all kinds of things. They want to add inulin as their sweetener because inulin is a prebiotic. They know they have to somehow stimulate the gut microbiota to have the good guys be the ones that are ruling the show, but it's not the same. They are adding potato starch to the diet because potato starch is a resistant starch. So they are trying to mimic what we would have naturally by eating whole plant foods, by adding things that have been extracted just to see if they can have the gut microbiota somehow also work nicely, but it's not the same.
Yeah. And just like animal products have no fiber, either do processed foods unless they have added them back in.
That's true. Yeah, that's an important point. We always say it's not about being vegan, because if you're vegan, you avoid all the animal foods, but you may still be eating foods that are depleted in fiber. The key here is fiber. If everybody needs to just pay attention to one thing, is the key to weight loss. I know this is not a summit about weight loss, but the key to weight loss and the key to gut health, both is fiber. And you can only find that in whole plant foods.
Right. And I think that's pretty much all the speakers emphasize the importance. You mentioned in addition to fiber, we want to eat resistant starch. Is that found primarily in beans, or can we find it in other types of plant foods?
Oh, no, we can find it in other types of plant foods. So resistant starches, there are 4 different types. I believe the first one is what we can get in, I cannot remember specific. I know type 4 is man-made. And I believe type 1 is what we get naturally in raw potatoes and raw green bananas. And then type 2, if I'm not mistaken, is what we would get in cooked potatoes, just different, or chilled pasta. And then type 3, I cannot remember the different. I know there's 4, there's 3 are natural. And I know, yeah, raw potato and green bananas will have 1 type, that's for sure. And then I know that if you cook certain carbohydrates, potatoes being 1 or pasta being another one, and you chill that food, then the resistant starch goes higher. And I know this is one of the things that you do, right? You usually cook your potatoes, you put them in the fridge, and then you heat them up. So you're getting a lot of fiber from those potatoes. A lot of people are afraid of eating potatoes, carbohydrates, I'm going to gain weight. And without knowing they're very high in resistant starches. In Brazil, we have a lot of African foods or heritage, so to speak. So we eat more cassava than potatoes. Cassava they're so high in resistant starches as well. And as I mentioned, any pasta that you cook and then you chilled and you reheat, so it can be a cold pasta salad, or it can be pasta that you just chill and then you reheat, they're all great.
Yeah, I do that not because I knew about this resistant starch, just because I do batch cooking and it was easier to do that than to have to cook potatoes or sweet potatoes every day.
But yeah, but it just goes to show that sometimes we are doing things that work without knowing why they work. It's just so nice that when people explain to us and say, oh, okay, this is kind of natural to me, but I love that happens. The same thing goes with adding vinegar to certain foods, right? So if you want to, Japanese, they cook their rice and it's white rice, but usually they add vinegar to their cooking rice. And that vinegar also helps blunt the glucose response, because think about it, vinegar is acetic acid, and it could be, and remember that one of the 3 short chain fatty acids was acetate. So that's pretty much what you would be doing. You can have the same effect on your glucose response either by eating the vinegar in your food with a high glycemic index food, or if you have a lot of fiber, gets to your intestines, and then the short chain fatty acids come. So it's top down or bottom up. Either way, the effect is going to be that equivalent.
That's incredible. It's like they knew what they were doing even before they knew why it was so important.
Exactly. So those are the things that you just can't explain, but people have been doing right for a long, long time. Yeah. It's just fascinating when we can actually understand why.
Right. So I don't think anyone on this summit disagrees about the importance of fiber, but one of the reasons we decided to do this summit was because after the Truth About Weight Loss Summit, so many people came to us saying, well, I'd like to eat more plants. I'd like to be vegan or whole food plant-based, but when I eat fiber, I get bloated. It's just so difficult. And yet beans, especially, which all the doctors say are so important, seems to be the food that they have the most trouble with.
Yeah, that's true. The thing is, there are a few reasons for that. One is it takes time for your gut microbiota to adjust to your diet. So if you've been following a diet that is low in fiber, and out of the sudden you start adding massive amounts of fiber, you will have some discomfort. There's no way around it. It's just massive amounts of fiber, and you don't have enough gut microbiota to handle that. So you need to pace yourself to give enough time for the good guys to outnumber the bad guys. So it takes time for you to get there. The other thing that is interesting, I read that in an article, and I think it's mostly true, is that you have to look for also the amount of fiber that you eat in a very short period of time. So they say that if you expect someone, so the average fiber intake that you would expect people to have would be about 35, right? 30 to 40 grams. That would be the bare minimum amount of fiber that you expect people to be eating. And if you make sure that in any meal, you keep the amount of fiber that you eat around 20 grams, it would be safer than trying to eat 30 grams in one meal. I know I do it, and I know I have discomfort sometimes because I eat most of my meals or most of my food in a very short window of time every day. Sometimes I have to pay the price, but I don't care because I eat my kale and broccoli and beans, everything within like 3 to 4 hours. Sometimes like 60 grams of fiber, or sometimes it's even more. And so it's important also to space it out. The other thing that people need to pay attention is like, not everybody drinks the bare minimum amount of water. Water is very important too. So it's about diluting what you are eating, drinking enough water, spacing your meals so that you don't eat a lot of fiber in one meal and then you go to another meal where it's depleted of fiber. Try to balance it out. And then at the beginning, if you want, you can there are some vegan enzymes that can help you digest some of these hard to digest carbohydrates. At the beginning, they help a lot. And then as your gut gets more used to it, then it can handle better. The other thing that you have to pay attention is that different people will tolerate different beans differently. So you have to play around and see which ones are the easiest for you, which is the hardest. Lentils may get people more trouble than chickpeas, for instance, or black beans. You just play around. There's so many different types of beans. There's no shortage of beans to try. And at the beginning, you may try to eat, instead of eating whole beans, eat beans in hummus or anything else that can make it easier for you. But you have to try. If you don't try, you're always going to have the trouble. It has to be gradual. And the thing is, it's a vicious cycle because you don't want to try and you keep eating low fiber and it continues to be bad for your health. Maybe you won't feel anything in your gut, but I believe that's the consensus in everybody that has been talking with you. There's no overall health without gut health. And it's impossible for our gut to be healthy unless we give our good guys the food they need, which are fiber and resistant starches.
I love it. And I know that sometimes having longer periods without food in the stomach is very good for people with GI disorders. A lot of the speakers talked about something called the migrating motor complex, where these cleaning waves occur. And if people are just putting food in their mouth all day, they never have a chance to rest and digest.
So I believe that to be true. Yes. Sometimes I have discomfort, like I said, it's just depending on what you eat, because I eat a few days more than 80 grams of fiber. And if you do that in a very short period of time, you may have some discomfort, but I don't care. I know it's making my gut microbiota happy. So if they're happy, I'm happy.
You know, what you talked about how people that count calories will always end up gaining weight. That's mind-blowing, because that's what so many people believe is the only way to lose weight.
Yes, I was listening to a book. It was a book on finance, of course, it's a given. But it was so funny that the guy says that there are simple rules about money, the same way there are simple rules about weight. Weight is all about calories in and calories out. If you eat less food and you exercise more, you will lose weight. And I say, should I continue to listen to this book? And I say, I will, because he probably understands about finance. He just doesn't understand that when it comes to weight, it's not as simple as that. We're not even talking about genetics, all the environmental effects, so epigenetic regulation. We're not talking about food cues, psychology, all of these other things that come into play that go even beyond. If you think about psychology, there's also a link between mental health and gut health. I don't know if anybody talked about this, but everything is linked, and it's not that simplistic. Otherwise, we wouldn't have a weight problem, because that's what people have been doing over and over again, eating less, exercising more, and it works for a very short period of time, usually 3 to 6 months. After that, everything comes back, because it's biology. It's what the body wants, to go back to where the body believes it's good for us to be.
Yeah, and then they go back and repeat the cycle.
Exactly. Just a different diet with a different name, but this time it's going to work.
Right. And you said something like 2/3 of the people gain it back and then some. I've actually heard the number might be even higher.
Yes. Well, this came from a review I read recently, and based on the articles that they were reviewing, they said is about 2/3 of the people. Yes. But depending, it may be almost 90% of people. Yes. But from this latest review that I remember reading, it was steady. 2/3 of people gain everything plus some, which is very, very important. It's not just gain everything plus 2-3 pounds to boot.
Well, the way you explained it with all those the chemicals that are secreted, that makes total sense. And this is something we're going to have to listen to again and again to understand. But it was amazing.
Yes, because it's very hard for us to understand. Why is it that you are counting calories, you lose weight at the beginning, you feel awesome and you exercise, but it gets to a point where you hit a plateau. And you believe, you just cannot understand why you hit a plateau. You hit a plateau because as you lose weight counting calories, your appetite is stimulated because you're not eating enough fiber and you're eating a lot of fat usually, right? But if you don't have enough fiber, you're not producing the short chain fatty acids or any of the other peptides, GLP-1, PYY, they're going to be decreasing hunger. So you're always going to be hungry and tired all the time because your cells are not receiving what they want, which is also a micronutrient-rich diet. If it's a diet that is depleted from fiber, you're not getting other micronutrients as part of it. So you are getting energy, but your cells are not able to produce energy because they're not receiving what they need to produce energy. And that's why you are tired also all the time. You don't produce ATP. You get energy, but your cells cannot produce energy with the type of food you are giving your cells.
It's such a win-win situation that what happens to be good for weight loss and weight maintenance is also good to have the most favorable microbiome.
Exactly. And if you have gut health, you have your overall health. It's not just about weight, it's everything works perfectly because of what we have here. We have to pay attention. And that's why I'm so excited to participate here. And I know people will love to hear everything that you have to say here and what the other experts have to say, because this is crucial. Everybody likes to talk about gut microbiota, but very few people understand how important this is.
Right. So, Dr. Oliveira, what is the truth about GI health?
Well, the truth about GI health is what I mentioned before, is eating a diet that is very high in fiber, very low in saturated fat, because this is the diet our guts love. And if our guts are healthy, our whole body is also happy and healthy.
Beautifully said. Thank you, Dr. Oliveira.
Oh, my pleasure. Mwah. Bye.